Hey guys, this is a homework problem that's been challenging a lot of you guys, so I want to make this video to help clear this idea up and help you guys figure this out. You can use these same ideas we talked about on this problem on the next two problems, which are similar but a little different. So the first thing you do anytime, so we're looking at this, we have a z value here, so that's telling us that we're dealing with the standard normal distribution. So we need to draw the graph. I can't emphasize how important that is. Looking at this problem, this is really confusing. How do I even start? Where do I go? But if we get a graph drawn with what we know, it helps so much. So, we draw our standard normal curve. Mean is 0. Okay. Now, what we are told is that the probability that z falls between 0 and a, so between 0 and some a value, that probability is 0.249. Now remember, probability and area have that kind of corresponding relationship. So that means that the area between 0 and a under this curve is 0.249. Now, since we're trying to find that a value, we know to go from an area to a data value, we need to use the inverse norm. So we know we are going to be using inverse norm. The problem is the area inverse norm takes in, the very first thing it says is the area, and it wants to know the area to the left of the value we're looking at. We want a, so we need the area to the left of a. But we don't know the area to the left of a. We know the area from a to 0. So how can I get the area to the left of a? Well, it relies on one really simple fact. And that simple fact is that a normal curve is bell-shaped and symmetrical. Symmetrical meaning that the area to the curve is equal to the left of 0 as it is to the right of 0. So if the area under the whole curve is 1, and we can split it evenly at 0, that means over here there must be an area of 0.5. So from 0 over is 0.5, and from a to 0 is 0.249. So we can just add those two numbers together and we get an area to the left of a of 0.749. And then we have a mean of 0 and a standard deviation of 1 because this is a standard normal distribution. And so let's grab our calculators. Okay, we're going to do second distribution, inverse norm. Now this is my calculator version, right? Depending on yours. 0.749. Okay. If you have a different version, once you hit inverse norm, it would give you this parenthesis. Then you just put 7.749, comma 0, comma 1, and we hit enter, and we get our answer, 0.67. Now remember, z-scores are rounded always to 2 decimal places, so we just keep this here. So a is 0.67. And there's our answer. That's it. It's that easy. We're so cruising now on this one. All right, you guys. Hopefully you guys can take that and apply that. Remember, this curve is symmetric about the mean. So if we know, say, equal distance from the mean on each side, we can divide that by 2 and get this chunk. Use the 0.5, do other things like that. So see if you guys can figure out these next two problems. The one that we have the probability of negative b is less than z is less than b, and the probability that z is greater than c. You'll see it on the homework. So with that said, guys, have fun on the homework. Good luck on the test.